Hello, welcome back to another lesson with our group, which includes Phương Anh, Tường, Khánh, Linh, Khang, and Minh. Now this week, we're going to be talking about trigonometry. Let's get into it, shall we?
First is Pythagoras theorem, and the next is 26.2 trigonometric ratios, calculating angles, and next is using sine, cosine, and tangent in function. 26.5 is which ratio to use. 26.6 is application of trigonometric ratios, problem in 3 dimensions, and sine and cosine of obtuse angles. And the next is the sine cosine rules, using sine and cosine to find the area of a triangle, and sine, cosine, and tangent of any angle. 6.1 Pythagoras theorem, definition. In the right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if we know the length of two sides of a right-angled triangle, we can find the length of the third side. But remember, it only works on right-angled triangles. So the formula is a squared plus b squared equal to c squared. Let's move on to the example. Calculate side c of this angle. So as you can see, as a step 1, start with the a squared plus b squared equal to c squared, and we put in the numbers that we know. So 5 squared plus 12 squared equal to c squared. And the next, step 3, calculate squares. 25.25 plus 144 equal to c squared. C squared is 169. The last step, square roots of both sides equal to 13. So next, testing for right-angled triangle. Step 1, does the formula a squared plus b squared equal to c squared, and does square root of 3 plus square root of 5 squared and equal to 2 square root of 2 squared. Step 2, does 3.3 plus 5 equal to 8? Yes, it does. So this is a right-angled triangle. So next, let's move on to trigonometric ratios. We have the 3 formulas, and the sine of the alpha angle is equal to opposite over hypotenuse, and the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay, so this is a special angles. So the trigonometric ratios of the angles 30, 45, and 60 can be easily expressed as fraction or surds. So students should commit this to memory, as it is really convenient in your examination. So next, move on to 26.3 calculating angles. So examples. How to calculate angles using your calculator. So the question is, what angle have a cosine of 0.6? So the first thing you do is that press shift on the calculator and then press the cosine button, and check that cosine minus 1 is equal to 53.1301, and it is equal to 53.1, so rather to 1 decimal place. So check that cos 53.1 is equal to 0.600, and you can do the same with sine and tangent. So next, using sine, cosine, and tangent in functions. So example, calculate sine, cosine, and tangent of angle C. So step 1, you know your formulas, and these are 3 formulas that we have discussed. So step 2, put in the numbers. So the sine of the alpha angle is 2.8 over 4.9, and the cosine is 4 over 4.9, and the tangent is 2.8 over 4. So step 3, we work out the outcomes, and the sine is 0.57. The cosine of the alpha angle is 0.82, and the tangent is 0.7. Next, move on to 26.5, which ratio to use. This is the example. So step 1, identify the information that is given. So in this figure, we have the hypotenuse has a length of 16 centimeters. X is the opposite of angle C, and angle C is 37 degrees. So step 2, decide which ratio to use. And according to the data we have known, here we will use sine. The formula of sine of alpha angle is opposite over hypotenuse, and the sine of 37 degrees is equal to x over 60. And step 3, calculate x. So x is equal to 9.63 and rounded to 3 significant figures. Let's move on to 76.6, application of trigonometric ratios. So the first is angle of elevation. If a person stands and looks up an object, the angle of elevation is the angle between the horizontal line and the sight and the object. So angle of depression, if a person stands and looks down at an object, the angle of depression is the angle between the horizontal line of sight and the object. So example, an architect wants to calculate the height of a building. He stands 50 meters away from the base of the building and looks up at the top of the building. So the angle of elevation from the architect to the top of the building is 70 degrees. To calculate the height of the building and give the answer to one decimal place. So let's move on to the solution. So step 1, label the side of the triangle, OA and H, as you can see in the figure. And the next step is identify your information. In the triangle, the length A is known and length O is unknown, so it must be calculated. And step 3, choose the correct ratio from sine, cosine, and tangent. And here we will tangents according to the statistics we have known. So step 4, put in the numbers you know. So the tangent of 70 degrees is equal to opposite over adjacent and is equal to 137.4. And step 5, conclude your answer. The building is 137.4 meters tall.
Let's get on to 26.7, problems in 3 dimensions. First, we'll discuss how to find an angle or side in a 3D figure. Step 1, you'll find the right angle triangle in the figure. The triangle has to include 2 known values that can be used in calculations. Step 2, you redraw this triangle separately as a plain right angle triangle. Step 3, add the known values and the unknown value you want to find. Step 4, use the trigonometric ratios and Pythagoras theorem to solve. Here's an example. A, B, C are 3 points at ground level. They are all in the same horizontal plane. C is 50 km east of B. B is north of A. C is on a bearing of 0.5 degree from A. An aircraft flying east passes over B and over C at the same height. When it passes over B, the angle of elevation from A is 12 degrees. Find the angle of elevation of the aircraft from A when it is over C. Here are some guidelines to solve the problem. Step 1, draw a diagram containing all the information known. Step 2, use the right angle BC to calculate AB and AC. AB equals 50 over tan of 50 degrees, which is equal to 41.95 kilometers, to 4 significant figure. And AC equals 50 over sine of 50 degrees, which is equal to 65.27 kilometers, to 4 significant figure. Step 3. Use right angle triangle ABX to calculate BX and hence CY. BX is equal to 41.95 multiplied by tan of 12 degree, which is equal to 8.917 km, to 4 significant figures. Finally, use the right angle triangle ACY to calculate the required angle of elevation. Tan of angle theta equals to 8.917 over 65.27 equals to 0.1366, which this makes theta equals to inverse tangent of 0.1366, which is equal to 7.8 degrees to 1 decimal place. Moving on now, here we'll talk about sine and cosine of obtuse angles. First, this is how to calculate the sine of an obtuse angle. Step 1, draw a circle with a radius 1 on your graph. Step 2, draw a right angle triangle, OPN. Sine theta is equal to NP and cos theta is equal to OP. Replacing this into P at XY, we have P cos theta and sine theta. Step 3, you draw your obtuse angle, P slash at X sine theta. And step 4, you conclude your answer. The coordinates of P and P slash on the y-axis are the same. So that means sine theta is equal to sine 180 minus theta. Secondly, here's how to calculate the cosine of an obtuse angle. Step 1. Draw a circle with a radius 1 on your graph. Step 2. Draw a right angle triangle OPN. Sine theta is equal to NP and cos theta is equal to OP. We have P at XY is equal to P cos theta sine theta. Step 3. You draw your obtuse angle P slash at minus cos theta Y. And step 4, you conclude your answer. The coordinate of P slash on the x-axis is the opposite or negative of P, which makes cos theta equals to minus cos theta 180 minus theta. Now, these are the short formulas of finding sine and cosine. If angle theta is obtuse, then sine theta equals to sine 180 degrees minus theta. And if angle theta is obtuse, then cos theta equals to minus cos 180 degrees minus theta. Now we will talk about the sine rule and the cosine rule. Here's a breakdown on what the sine rule is. Step 1. Draw the vertices of the triangle to the opposite of a side. From right angle triangle ADB, H equals C sine B. From right angle triangle ADB, H equals B sine C. Therefore, we have B over sine B is equal to C over sine C. Step 2. If you draw the two other vertices to the opposite side, you'll have A over sine A equals to C over sine C, and B over sine B equals to A over sine A. And step 3, this can be combined in the form A over sine A is equal to B over sine B and is equal to C over sine C, or written inversely as sine A over A is equal sine B over B and equals to sine C over C. Now we discuss what the cosine rule is. Step 1. Use the Pythagoras theorem. Triangle BDA has h squared equals to c squared minus x squared, and triangle ADC has h squared equal b squared minus a minus x all squared. Combining these, we have c squared equals b squared minus a squared plus 2ax. From triangle BDA, we have x equals c squared cos b, so we have c squared equals b squared minus a squared plus 2ac multiplied cos b. From there, we get b squared equals a squared plus c squared minus 2ac cos b. And we have a squared equals b squared plus c squared minus 2bc cos a. And also c squared equals a squared plus b squared minus 2ab cos c. And lastly, we have step 3. You only need to remember a squared equals b squared plus c squared minus 2bc cos a. And step 4, those three formulas can be rearranged to cos A equals b squared plus c squared minus 2 squared over 2bc, and cos B equals a squared plus c squared minus b squared over 2ac, and cos C equals a squared plus b squared minus c squared over 2ab. On the screen now is the summary of the sine and cosine rule. You can stop the video now to take some notes. Okay, now we'll discuss how to use sine and cosine to find the area of a triangle. Here are all the formulas you can use to find the area of a triangle. S equals a half of AC multiplied by sine B. S equals a half of AB multiplied by sine C. And S equals 1 over 2 of BC multiplied by sine A. Here's the first example for you to practice using the formulas. Look at triangle ABC and think carefully of how you are going to solve it. Okay, let me guide you through the steps now. Step 1, write down the formula. S equals 1 over 2 multiply AB multiply sine C. Step 2, put the numbers you know into the formula. S equals 1 over 2 multiplied by 5 multiplied by 7 and multiplied by sine 38 degrees. And we will get 10.8 centimeters cubed to 3 significant figures. Next, we have the second question. This time we use both cosine and sine to find the area. Step 1. Use cosine rule to find angle C. Cos C equals 13 squared plus 19 squared minus 8 squared over 2 multiplied by 13 multiplied by 19, and we will get 0.9433. Therefore, angle C equals inverse cos of 0.9433, which is equal to 19.4 degrees. Then step 2 would be to find the area using sine. Area equals 1 over 2 multiplied by 13 multiplied by 19 multiplied by sine of 19.4 degrees. And we will get 41.0 centimeters cubed to 3 significant figures. Great, now we'll talk about sine, cosine, and tangent of any angle. For acute and right, cos theta and sine theta are both positive, and for obtuse angles, cos theta is negative and sine theta is positive. You can use the same idea to find the sine and cosine of a reflex angle, that is an angle bigger than 180 degrees. For angles smaller than 270 degrees, sine theta is negative and cos theta is positive, and for angles smaller than 360 degrees, cos theta is negative and sine theta is positive. Now on the screen you can see a graph that shows the sine of any angle between 0 degrees and 360 degrees. Notice the symmetry of the graph. The graph y equals sin of x degree suggests that 55 degrees and 125 degrees have the same sign because 180 minus 55 is equal 125. So we say sine of 55 degrees is equal to sine of 125 degrees, which is 0.81923 decimal places. This is another graph that shows the cosine of any angle between 0 degrees and 360 degrees. The graph y equals cos x degree suggests that 70 degrees and 290 degrees have the same cosine because 360 minus 70 degrees is equal to cosine of 290 degrees, which is 0.342223 decimal places. You will need to remember the shapes of these graphs and their symmetries. Now let's solve a simple problem to practice using what we have learned, okay? The question asks us to solve the equation, giving the answer to the nearest degree. Sin x equals 0.03 with 0 degree smaller or equal to x smaller or equal to 360 degrees. A calculator will give inverse sine of 0.03 equals to 17 degrees. This is one answer to the question. Now look at the symmetry of the sine graph. We have 180 degrees minus 17 degrees equal 163 degrees, and this is the other answer. Finally, you conclude your answer, saying x equals 17 degrees or 163 degrees. Then we have the second example, which is a little bit more complex, but still easy. Sin x equals minus 0.3 with 0 degrees smaller than x smaller than 360 degrees. Using a calculator, you will find inverse sine of minus 0.3 equals to minus 17 degrees. And we know that minus 17 degrees is a clockwise turn of 17 degrees. It is the same as an anti-clockwise turn of 343 degrees. So one answer is 343 degrees. To find the second answer, we look at the graph and calculate 180 plus 17, giving us 197 degrees. Finally, we conclude that x equals 197 degrees or 343 degrees. Now, this is another type of question you may come across. It asks you to solve 2 cos y plus 1 equals 0 with 0 degrees smaller than or equal to y smaller than or equal to 360 degrees. First, we rearrange the equation to get from 2 cos y plus 1 equals 0 to cos y equals minus 0.5. Using a calculator, we get inverse cos of minus 0.5 equals to 120 degrees, and the other answer would be 360 degrees minus 120 degrees equal 140 degrees. Lastly, we conclude the answer, which is y equal 120 degrees or 140 degrees. Next, here's the formula to define the tangent of any angle. Tan theta equals to sine theta over cos theta. Here's a graph of y equals tan x where 0 degrees smaller than or equal to x smaller than or equal to 180 degrees. The section from 180 degrees to 360 degrees is identical to the section from 0 degrees to 180 degrees. This means that tan of 10 degrees equal to tan of 190 degrees, and tan of 20 degrees equals to tan of 200 degrees, and so on. Let's look closer into the graph. The graph is in three separate branches. The lines x equal 90 and x equal 270 are asymptotes. The graph gets closer and closer to those lines as y gets larger. In case you don't know what are asymptotes for the graph of a tangent function are vertical lines that occur regularly. Each of them are 180 degrees apart, and they separate each piece of the tangent. Let's practice this through some examples. Solve the equation knowing tan equals 2 with 0 degrees smaller than or equal to x smaller than or equal to 360 degrees and give your answer to one decimal place. A calculator gives the inverse tan of 2 equals to 63.4, so this is one answer. From the symmetry of the graph, another answer is 180 plus 63.4 equals 243.4 degrees. In conclusion, the two answers are x equal 63.4 degrees and 243.4 degrees. Here is the second example, which is a little more advanced. Solve for tan x plus 3 equals 0 with 0 degrees smaller than or equal to x smaller than or equal to 360 degrees and give your answer to one decimal place. Firstly, we rearrange the equation and get tan x equal minus 0.75. A calculator gives the inverse of tan of minus 0.75 equals minus 36.9 degrees, but this is outside the interval of 0 degrees smaller than or equal to x smaller than or equal to 360 degrees. However, minus 36.9 degrees is a clockwise turn of 36.9 degrees. It's the same as an anti-clockwise turn of 323.1 degrees. So one answer is 323.1 degrees. By the symmetry of the tangent graph, another answer is 323.1 degrees minus 180 degrees equal 143.1 degrees. We conclude that the two answers are x equal 143.1 degrees and 323.1 degrees. And that's the end of the lesson on chapter 26. Thank you all for listening and see you next time.